Guys, happy Sunday and welcome back. In today's video, I just want to carry out the calculations and the solutions of your practicals because I realized that so many persons actually missed out from the class. So to avoid attending to questions one after the other, I thought it wise to make the video so that everybody can take part in it. Okay, so far we have three practicals that we're going to be talking about in this video, their solutions as well. Everyone has carried out experiments 1 and 4. The experiment 7 is definitely going to be the next practicals you're going to carry out in the lab from Monday. Okay, please, before I proceed, I want to appeal to us to just hit the subscribe button. Just click on the subscribe button and hit the bell notification so that you'll be getting subsequent videos. At least the time and the effort we're dedicating making the videos, the least you could just do to support us is just to hit the subscribe button. So thank you very much as you do that. Okay, so we're definitely going to be talking about the calculations of experiment 1, after which we proceed to that of experiment 4 and then experiment 7. Okay, so let's start off with experiment 1. Now this is a data table. I saw a lot of values, a lot of persons were texting me to confirm if their values are correct and the rest of them. But I realized one thing, right? For this first 3, we have this first 3. That's the simplest steps amongst all the steps. Okay, so let's impute the values here. So if you look at this guy, this place is supposed to be just give me 1 minute. Oops. Sorry about that. So here now we have we have 25 degrees. This place was 25 degrees, and then the density is 0.9973 gram per mils. Now if you actually realize this, now these values, this particular phase value here, you don't have to stress yourself because the value will be given to you guys in the lab, right? These values will be given to you guys in the lab. So this is 25. Don't mind the way I wrote this degree. This is 25 degrees Celsius, the temperature of the water, or perhaps the temperature of the lab, and then you put comma. This comma is actually to demarcate the temperature from the density of water. So the density of water is 0.9973. Some persons claim they didn't give them in the lab, but I actually believe that maybe you guys did not really take into consideration, or perhaps look towards that direction, because I know they used to give the values in the lab, but because of the hustle and bustle in the lab, maybe some persons actually forgot to ask. All right, the next one we're going to be looking at is the we have the mass of the LMAR flask and volumetric flask. Now if you look at this, remember sometime last week we carried out this particular experiment, and then the mass of the 10 ml volumetric flask, we got 16.5 with the cover, right? But I was seeing a lot of some persons having 16.5, 17.5, some persons were even having as low as 13, right? There's nothing to bother about. All the flasks may not necessarily be the same. So I'm going to be using, because I saw this from people that carried out the experiment, I was so we have 16.1 grams. All right, but if your value is actually within the range of 13, let's say 13.5 to let's say 17.5, if your range is within this value, you have nothing to worry yourself about. You're still within the right value data. So everybody must not have 16.1. It's actually not possible. And the various volumetric flask, their masses may not necessarily be the same. So if you got 13.5 up to 17.5 or 17.75, I think you're very correct. I doubt if there will be anyone that will get to 18, except the flask is 25. But I learned everybody used 25 mil. So that is that for the you know, mass of the 10 mil. Okay, now for this second one, mass of the we have, when you now fill the 10 mil flask with water, when you fill it with water, you know, we have 26.1 grams. Okay, but some persons, their values definitely will not correspond to 26.1. But if your value is actually within the range of if your value is actually within the range of 23 grams to 27 grams, I think you're good to go, because like I said, it's actually practical, so most of the times they tend to be errors, right? You can, you know, maybe some persons may not be able to measure the water accurately. So the ones inside the brackets are the range of values, right? The possible values that people can get for these particular ones, but the ones I'm going to be using are the ones outside the brackets for my calculations. So basically this video, if you're not very certain of your results, your data, right, trust me, you can just take what I'm going to put here, because what I'm trying to do is that this particular one by 1 to 3 is the same thing, since everybody used 10 ml volumetric flask, so the answer has a range of value. Now mass of other flask plus, you know, liquid. Now the other flask here, the other flask we made use of, the other liquid we made use of was ethanol. All right, so we have this to be 1 minute. Let me, you know, pull back my line. Okay, so we have so for this second one here, you know, when you now that same volumetric flask, right, with other liquid, now the value I'm going to use, I will use 23.6. These values I got from students as well. But if your answer is within the range of 22 to 24 grams, 22 grams to 24 grams, I think you're good to go. Yeah, you're very good to go, because remember, everybody, they tend to be error, obviously. Yeah, so it's the range we're looking out for. So the ones outside the brackets are the ones I'm going to use for my calculations, right? And the ones inside the brackets are the ones just to correspond to your values. Now, the mass of LMAR flask. Now, at this point of LMAR flask, I learned that some persons did not make use of LMAR flask. Yeah, that's from the information I got. Some persons did not make use of LMAR flask. So in this case now, what exactly are we going to do? Some persons made use of beaker. Some persons made use of 50 mil LMAR flask. Some persons made use of 25 mil LMAR flask. So the big question is, which of them are we going to use? Now listen and listen very carefully. This LMAR flask, it was actually used so as to be able to get the volume of the pipette. So you actually measured the pipette, you measured water from the pipette and transferred it into the LMAR flask. So whatever the mass of the flask or the beaker, whatever you made use of, class, is not going to affect your answer, because at the end of the day, you're going to subtract the mass of the LMAR flask or the mass of the beaker from the mass of the flask plus the aliquots. All right. So let's look at this. Some persons used 50 mil beaker, 50 mil beaker. All right, 50 mil beaker. So let me just come here and say, now what I'm using here is 50 mil beaker. So if you use 50 mil beaker, what exactly are you expecting? Some persons use beaker, sorry, some persons use LMAR flask. So the question now is, which of them did you make use of? But regardless of whichever of them you make use of, class, there is nothing to bother yourself about. All right, so some persons made use of 50 mil beaker, and the 50 mil LMAR flask rather gave them, you know, so the values they got here So we have 32.95 grams. Now the range of value here should be 32 to 40 grams. Yeah, this is the range of value. So if your answer falls within this range for 50 ml beaker, remember what we are using here is actually for, we say 50 ml LeMaitre flask. Okay. All right, so let's leave it on red ink. So my value here for 32 for the LeMaitre flask, I got 32.95. Now remember, like I said, some persons made use of beaker, some persons made use of smaller LeMaitre flask. So your number 4 value might not correspond to other people number 4 value. You don't have anything to worry about. Right, this 50 ml LeMaitre flask, the range of values you're possibly going to get is 32 grams to 40. So if you made use of this, you can write it down. For those persons that are not sure of what they made use of, class, listen up. Since the lab, they ask you guys to use a LeMaitre flask beaker. If you're not sure of what you made use of, please, instead of you to write a wrong value, you can just get the value I'm giving you guys here. Because these values, when they are marking it, they'll mark it pertaining to what you made use of. So you can see what I did here. I had to indicate 50 ml LeMaitre flask so that anybody that is marking this manual, once he sees this, he understands that, oh, for 50 ml LeMaitre flask, this is what I'm supposed to have. And for 50 ml LeMaitre flask, not everybody is going to have 32.95. Some persons might have 32 to within this range, because there's not how it's going to be just one LeMaitre flask, right? Different flasks and different weights. Okay, but regardless of the flask you're making use of here, okay, the answer here is not supposed to be different for everybody. Every single person is going to have the same values or within the range for this particular one. Now I will explain to you guys. Now this is not the time for me to start explaining the practicals, right? So just follow up and see what I'm going to do here. Now if you have for instance, you have, we just want to fill this table first so that we understand what we're looking out for. If I have so here, this particular place is most likely going to be, remember we are trying to solve this value. Okay, so here now is going to be, remember they said average, all right? So this average simply means, let me explain this part now. This average simply means they gave us 25 ml LeMaitre flask, right? So this is what is going to happen here. Let me use my pen. I'll have I'll say this is let's say the mass of the LeMaitre flask is, for example, is 32.95 grams plus, right? You add the first 25 ml. Since water has the density of 1 gram per ml, so it means that 25 ml of water will obviously give us 25 grams. So this is 1225 plus 25 divided by 3, right? If you do that calculation, this is going to be 25 times 3 divided by 3. That gives you 25 plus 32.95. All right, that is going to give you 57.95. Now the 57.95 is basically the mass of the flask, a LeMaitre flask, plus mass of the average of the liquids after 3 times. Remember, average means for the 3 times you're going to divide it by 3. Some persons actually would add the 3 times and then get the mass. But please, before you take the average, subtract the mass of the flask from it before you take the average. But like I said, this is not the time to be explaining the practical solution. Now it's for us to get the value. Now what you're going to write here is actually not going to be the mass of the flask plus the liquid. You're just going to write the mass of the content, right? Which is going to be the mass of the content here. So let's get this out. So what would be the mass of the content? So we have this to be 20. We have this here to be 24.5 grams. Now, please, this place is supposed to give the range of value you're supposed to get here, right? It's supposed to be, let's say, 23 to 26 grams. If you get the range, if your range of value is within 23 to 26 grams, fine and good, we are good to go. But if your range of value is actually not, okay, now look at this, the range of value here, the real answer you're going to write is you're not supposed to include the mass of this flask, right? You're not going to include the mass of this flask. You're not, right? You're going to, whatever you have, the mass of flask plus this aliquot, you're going to subtract what you're going to have from this mass of Erlenmeyer flask when it was empty. So when you actually add the aliquot, right, you can add it 3 times. After weighing it, the mass of the flask will still be involved. If you weigh it 3 times, right, you can subtract the mass of the flask out of it and now take the average, divide by 3. Whatever the answer is going to give you, you're going to write it here. That was the instruction given to them in the lab. So here is not supposed to bear the mass of the flask. It's supposed to bear the mass of the liquids alone. Right, so for water is supposed to give us 25 grams, since the density of water is 1 gram per mil, but we're going to write it 24.5. So the range of values here is supposed to be 23 grams to 26 grams. So if your value is within this range, so that means you're very good to go. Now for that of ethanol, we say for that of ethanol, now what are we going to get as our answer? It's actually very, very simple. Now, if you carry out the experiments, you realize that this particular value is supposed to, here I made use of, I'll use it to be 19.5 grams. Now, but the range of values here is supposed to be 19 to, let's say, 21. Yeah, 19 grams to 21 grams. Okay, so now look at this very well. For this guy, we have 24.5 grams. Please, these values are not assumed values, right? If you did what you're supposed to do in the lab very well, the only thing that actually may not be the same is number 4. Why? Because some persons use 50 ml Erlenmeyer flask, some persons use 25 ml Erlenmeyer flask, while some other persons used beaker. Right? This is only number 4 that is supposed to be different, but every other value is supposed to be the same, because these values here, you're going to subtract this when it was empty from what you're going to get with the mass. So what you have here is just the mass of this aliquot A, which is water, and mass of aliquot B, which is this guy. Right, you have no business to write in the mass of Erlenmeyer flask. You subtract it, right? If I had used beaker, you would have subtracted what you've got in between this and this from this. Okay, so this particular one now, we're not going to really make use of it, so we're going to skip it and move down to this number 15. But you can still record this if you want, but we don't need it for calculations, so I will just skip it for now. Okay, so for this guy, now if you look at this first one says you're going to weigh, please, this particular guy here, we're going to do what we did to this previous one. Let me show something. Whatever we're going to have here, right, this we're going to do it the same way we got this. You're not going to record the mass of the flask, you're just going to record the mass of this content. 15 plus 5, 15A and 5B is just the mass of the content you're going to, whatever you have with the mass of this plus the Erlenmeyer flask, you're to subtract it from this flask, right? So what we're going to have is just the contents. All right, so without wasting so much time, I'll just give us the values and the range of values that you're supposed to go with. All right, so this guy, we have 18.71 grams. But the range of this value, if you have 18 to, let's say 17.92 grams to, let's say 19.1 grams. Okay, so it's actually correct. This is the range of values here. All right, so for the second one, if you have this one now have 13.71 grams. So the range of these values, if your answer fall within this range, you're definitely still going to be correct. So if you have 13, you have 13 to, let's say 14.5 grams, you're still very correct here. And then please, these particular values here, right, from those persons that did their practicals, I got the value because it's actually, I got the value from their manual, which they said it was the coordinator that carried out this particular experiment, and obviously it still corresponds to what we're expecting to get. So for this third one, remember the mass we are recording here is just the mass of the contents. We are not adding the mass of the flask there. So this one is going to be 17.5 grams, and the range of this value, if your range is within let's say 17 grams to let's say 18.5 or 0.8 thereabouts, obviously you're still very correct. So why am I using this range of value? So that you don't have to stress yourself. All of them is still going to be the same answer. Now for this one here, we have 12.7 grams. All right, so this, your value should be within the range of, let's say 12 to 13.7 or thereabouts. All right, but if your answer is slightly above this 13.7, you're still very correct. Okay, so for this second one here, for this last one, we have 16.81 grams. All right, so if your answer is within the range of 16 to 16 grams to 18 grams, I think you'll see very correct. Remember, we are working with range. Okay, so guys, if you look at these values here, these values are actually the right values. It's actually correct values. Your value should be within, if you don't have exactly what I have here, your value should be within what I have inside the bracket, except this particular number 4. This number 4, if you had made this of 25 ml Elemea flask, your value should be within 20 something, right? If you had used beaker, 50 ml beaker, 100 ml beaker, apart from this value, right, this is the only one that might differ from all your manuals depending on what you made use of. But if you did the right thing, this place is supposed to be, if you don't have exactly what I have here, it should be within this range. All right, so in my calculation, I'm basically going to be using what I have outside the bracket, right? So if you're not sure of your answers, you can actually use mine. Trust me, when they want to mark your manual, right, they mark individually. They don't really start going through group. You do your practical as a group, but your calculation, you do it individually, because that was the sole essence of taking your manuals back home. You don't expect everybody to stay in the same house to carry out your calculations the same way. As a matter of fact, if everybody should have the same answer, it even calls for alarm. All right, so you don't really have anything to bother yourself about this. Trust me. If you have any question, do not forget to reach out to me, Delzy. Okay, please do not forget, before we move down to the calculation page, please, if you have not hit the subscribe button, please do well and do so while we proceed. Okay, so we are done with the first this is the data table. Like I said, this particular one now, it's not really necessary, right? So I'm just going to skip this guy. All right, so let's dive into the calculation part now. But let me tell us something about this. Remember, in this case now, right, the volume 15 plus 5, when we want to solve for the density, is this volume we are going to make use of. And remember, since there are two liquids, when you add 15 plus 5, you're expecting 20, but in real sense you're not going to get 20 because the two liquids are not the same. So you're going to get something less than 20. All right, so the volume they actually gave them in the lab, all right, what the attendant actually gave them when they mixed this together, I'm just going to write it at this corner, just somewhere around this corner, right? So I'm just going to say somewhere around this corner. I'll just say volume of mixture. All right, so this is the volume of the mixture, right? So all right, the volume of the mixture. Remember I said when you mix both of them together, obviously you're not going to get the same thing, right? So normally if you mix 15 plus 5 is supposed to give you 20, right? But since these two mixtures are two different liquids, volume will not be conserved. All right, so we're going to have the expected volume in this case to be 20, while the actual volume to be less than 20. So they conducted this particular experiment in the lab, and guess what? They got their for this first one, they got their actual volume to be 19.9 mil. Sorry, we got here to be 19.9 mil, and they got here to be 14.8. We got here to be, you know, you can manipulate this particular one here, right? If you add it up, instead of writing, for example, 10 plus 10 is supposed to give you 20, you can just remove 0.1 or 0.2, but don't record 20 on the dots. 10 plus 5 is supposed to give us 15, but I remove 0.2. So it's 14.8. On no account should you use this 15. The answer would definitely will not be different. The answer will be the same if you use 20 instead of 19.9. But they want to see you actually understand that when you mix two liquids, the volume will not give you the same thing. So 10 plus 5 plus 10 is supposed to give me 15. But I'll come here, I'll say I'll just write 14.8, and here I will just write 19.9 mil. So whenever we are solving for density of this mixture, this is the mass of the mixture, right? For this first mixture, this is the mass of the first mixture. So if you want to say density of this mixture, is going to be this mass all over this volume to get the density of the first mixture. If you want to solve for the density of the second mixture, you say this mass. Remember, this is the mass of the mixture. We had actually subtracted the mass of the flask that this mixture was contained in. So what we record here is just the mass of the contents of that flask, not the mass of the flask plus the contents. When you weigh it, you're going to get the mass of the flask plus the contents, but you have to subtract the mass of the flask and whichever flask you had made use of. I just realized that I got a lot of values yesterday, so I had to just compare. I was comparing the values, so the values corresponded to, obviously, so this is more like if you do not have exactly what to write, regardless of whether or not you actually are paying attention in the lab, you can just use these values to solve and you're going to get the same answers. Now, but this value, just made a little adjustment. The earlier video recorded here was 23.6, but I just had to take it to 24.0 due to the various values I got yesterday. But if you look at the range, it's still within the range. So apart from this, every other thing I think is intact. Okay, so this is actually where we're going to be recording the answers we're going to be getting from the calculation. All right, for those persons that have been asking the pattern on how to report their manuals, all right, so this is exactly, you're going to, this one is already on your manual. You write your title, you write your objective, and very, very important, please write down your apparatus, the apparatus you made use of in this experiment. Of course, we have Elemea flask, we have Elemea flask, we have beaker, we have pipettes, we have weighing balance, All right, please, when you're done with the apparatus, you can now put down your reagents. All right, it's supposed to come under here. Okay, let me actually it's supposed to come under here, but then so let me just put it down because it's very important. We need okay, so you come back here and then your reagents, very important. You need your reagents. Reagents, we had ethanol and we have water. Please, your date is very important. Make sure you put your date. All right, after which you can now start your calculation. But please, before we dive into the calculation, please hit the subscribe button below. At least you tend to get all the other practicals that will be dropped shortly. Okay, and also to help us, to encourage us, because to run this video is actually not very easy, editing and compiling. So the least you could do to support us and encourage is just to hit the subscribe button. Thank you very much as you do so. Now, so let's go back to this. The first calculation here is calculation of volumetric flask volume. All right, so the formula is V flask equals to mass filled with water minus mass filled when it is empty. The mass is the volumetric flask. Now from the table we got 16.1 for the mass filled is 26.1. Density of water is this. So simply insert this into the formula. We have this to be 26.1 minus 16.1. This is divided by, sorry for the space, 9973. All right, so this is going to give us 26.1. It is going to give us 10.02, which is approximately equals to 10 mil. Please, if you carry out this calculation and you got 9 point something to, let's say, 10, you're very correct, right? Because some persons will be like 9.8. Let me round it up. You don't have to round it up to 10. Whatever the answer is, you're still going to be correct. All right, so we move down to the next calculation, density of the second liquid. The second liquid in this case is ethanol. All right, so remember I made little adjustment to the mass of the ethanol when filled with mass of the flask when filled with ethanol. Previously it was 23.6, but after going through the values I was sent to last night, so most of the values were towards 24. So I decided to make this guy to be 24.0 grams. All right, so this is what we are going to do with our calculation. We now say density of ethanol. All right, density of ethanol, the formula is already here. Density of ethanol. So we'll now say density of ethanol. All right, now this is going to be the mass filled with ethanol is 24.0 minus mass when it is empty is 16.1. Now this is divided by the volume of the flask. We got here to be 10. Remember, even if you got 9.8, 9.9, you're still very correct. Your answer will not be that much different. So we'll say 24.0 minus 16.1 divided by 10. So we're having 0.79 gram per mil as the density of ethanol. Please remember that this value is not compulsory. Everybody will have 0.79. If your value is within 0.75 to 0.84, you're 100% very correct. In practicals, they mark the range, right? So if your value is within this range, that means that's a butter solving. You're in for your full mark. Okay, for the volume delivered by the pipettes. Now remember they told us to carry out they gave us 25 ml pipettes and you were asked to do it 3 times and then take the average. It's very simple. So it's either you do it once, the mass of 1 time pipette is still equivalent to mass of 3 times. Just that since you're going to be using your mouth, because I learned they didn't give you guys pipette soccer. So For accuracy's sake, for some persons carry it out 3 times, some persons did it once. If you carry it out 3 times and divide by 3, it's still equivalent to carrying it once. Alright, so we actually proceed back to our table. If you remember, this was the mass of our mass of the aliquot A. This 24.5, we actually did not include the mass of the LeMayer flask. We subtracted it, what we got subtracted from the mass of the LeMayer flask. So those get the mass of the content alone. So mass of water is 24.5. Mass of water delivered by the pipette is 24.5 grams. Now density of water is 0.9973 from our first data table. Alright, so we now say the volume delivered by the pipette. Volume of water delivered by pipette. This is volume delivered by the pipette. Volume of water delivered by the pipette to now be mass of water, which is mass of water is 24.5. Mass of water divided by the density of water. Just use that formula. Mass of water is 24.5. Now density of water is 0.9973. This becomes equals to 24.5 divided by 0.9973. So have this to be 24.6. This is 24.6. So the volume of water delivered by the pipette is actually 24.6. Alright, so let's dive into that of ethanol. The mass of ethanol delivered by the pipettes was 20.5, right? I'll just 20.5, right? So I think 20.5, we have okay, just give me 1 minute. I think please, this particular value was I think 19.5 previously. Sorry. So if you check out the video played earlier, I think so it is 19.5. So remember, this 19.5 was what I did the one I got earlier. So mistakenly I had to change it to 20.5. I didn't know. So now please remember that if your value, right, is within 19 to 21, you'll see very correct. But the ones I got 19.5, so I'm going to use it because I'm very sure of this value 100%. So if you carry out your practical very well in the lab, irrespective of your lab, you're supposed to get a value within 19 to 21. Okay, so we come here. The mass delivered by the mass of ethanol delivered by the pipette is, we have 19.5 grams. Now density of ethanol from our previous calculation, if you look at this previous calculation, we got 0.79, but I said your answer could range from 0.75 to 0.84. okay, so we're now going to say volume of ethanol delivered by pipettes this is the mass of ethanol. Mass of ethanol is 19.5, and then the density of ethanol is 0.79. So when you press this, you now have 19.5 divided by 0.79. So this becomes 24.6. Wow, 24.6 mil. So remember, when we are done, I'm going to show us where to record all these values. So for now, let's finish our calculation first. So we are done with the volume of pipette, right? But okay, let me just show us first. In the first one, volume of flask, we got 10 mil, and density of the second liquid, we got this. So this is where we're going to record. You come to this place. This is the first, we got 10 mil. You can put it on both sides, 10.0 mil. By density of ethanol, we got 0.79 gram per mil. Volume of transfer pipettes, right? For water, remember this first one is water, the second one is ethanol. For water, this number 3, for water we got 24.6, for ethanol we also got 24.6. So I'll come down here, I'll say this is 24.6 mil, this is 24.6 mil. Okay, how about some persons that will not get 24.6 mil on the dot? Please, whatever you're supposed to get, the range of value here should be between 24 to 26 at most, right? So it should be between the, but I would prefer it to be less than 25 because the pipette is 25. There is no how the pipette, your volume, calculated volume, should be more than 25, but in case you have 26, it's still very okay. So the range of value here is 24 to 25. So you come down here, and volume delivered by pipette is 24.6. Now let's look at this expected volume. Now for here we have expected volume. Okay, so for this particular one now, this expected volume, what are we going to do here? A lot of persons asked me some few questions. Now please, this is actually volume of pipettes. All right, now in this case now, please, this expected volume is actually the volume of pipettes because they gave us 25 mil pipettes. All right, now I can remember in class I told us that expected volume is 25, actual volume is 25. I just did that to save time. But for those persons that may want to really ask me why, because a lot of persons came to me and say, Sadeos, why do you say we should take it 25? Now, if you want to carry out the calculation, the actual volume, right? We say actual volume for water and ethanol. Please, the actual volume is actually the answer obtained from number 3, obtained from 3. Now, which of the 3? This guy here. Now, this for the actual volume for water is 24.6. The actual volume for this is also 24.6. So that is why I say you should take it to be 25, because it's going to be approximately equal to 25. Right? But for those persons that may want to say, why did we say, what if I don't want to write the approximate value? Now the real value for this guy is the answer we're going to get from the number 3 when we solve for water and when we solve for alcohol. So for this particular one here, the actual volume for water, from our calculation in number 3, we got 24.6, and then we got 24.6 as well for ethanol. So we say actual volume, expected volume is the volume of the pipette, which is 25 mil. The actual volume for water is 24.6, the one we got from number 3 calculation. That of ethanol is also this. So I will say, so therefore, actual volume is a volume obtained from number 3 question, right? So that is the actual volume. So for water we got 24.6 mil. For ethanol we also got 24.6 mil. Remember I said the range of this value is always 24 to 26. So your own does not have to be 24.6. Your own can be 23.24.5, 25.0, and the rest of them. But if you don't want stress, if you don't want problem, you can just write 25, which I told us in class. But if you actually want to carry it out the way it's supposed to be, the actual volume is the answer you got from this number 3 calculation. So you come here, and here you put expected volume. Remember, expected volume is the volume of the pipette. The pipette is 25.0 mil and 25.0 mil. The actual volume should be the same thing as this number 3. All right, so this is 24.6 mil and this is 24.6 mil. Hallelujah. Please hit the subscribe button if you have not done so. This is going to be very, very interesting and a long ride. It's best you see how we are doing the calculation, should in case, very, very important, should in case you're called upon to defend this, because for for the fact that they gave you a manual to take back home, they might actually ask you all to come defend your solution. So that is why I think it's wise to just solve it and explain it here instead of just dropping the answers on the group chat. Okay, so the last but not the least is the density of the mixture. Density of the mixture. Density of mixtures. Okay, so we have the first mixture. Now recall that density is equals to mass. This is always equals to mass over volume. I want you to recall that. So this is always a formula for density. Alright, density is always mass over volume. Okay, so we have so basically what are we going to do here? We're going to get the mass of each of them. Mass over volume. Sorry, I'm just trying to get so we have this to be alright, so we're going to say for the first mixture. Remember, we've gotten the mass of the first mixture. The mass of the first mixture, the content is 18.71 grams, which I said if you have anything within the value of 17.9 to 19.1, you'll see very correct. And the volume of this mixture is 19.9. Remember, since you're mixing two different mixtures, right? What you're expecting from 15 plus 5 is 20, but the actual volume after mixing it will be less than 20. So when we did that in the lab, it gave us 19.9. Okay, so please do not use 20 here because you're seeing 15 plus 5. Yes, it might appear to be 20 because that is what you're expecting, but in real sense, whenever you're mixing two different liquids, right, the volume is always not conserved, right? You always get something lesser. So the volume of the mixture is rightly written here. The first mixture is 19.9. The second one is 14.8. So let's dive into this. So we say for the first mixture, that is 15 plus 5. All right, now mass of this mixture, equals to 18.71. Mass of the mixture is 18.71, right? From what I gave us, this is it, 18.71, and that's the mass of the mixture. Now the volume of that mixture, now say volume of mixture is equals to 19.9 mil. Please, these values, if you're not very sure of what you did in the lab, you can transcopy this and put in your manual. The highest thing you can do is just to adjust the value by 1 decimal place, or take it up by 1 decimal, or reduce it by 1 decimal, because this video, as you're watching it, some other persons are watching it. So instead of you guys to have the same value also, you can just alter yours by increasing one value or decreasing it, and then press your calculator. So for example, instead of using 18.71 here, I can decide to use 18.72. But if you don't want problem, to avoid mistake, you can still use this exactly the same value here. All right, there's nothing wrong with that. Okay, so now say, so therefore density of that mixture equals to the mass of the mixture all over the volume. Now the mass of this mixture is 18.71. The volume is 19.9. So we'll have 18.71 divided by 19.9. So we have 0.94 gram per mil. That is the density of the first mixture. All right, so why are we going to record that, guy? You come back here. Yeah, you can see two lines here, but you're not going to write on the both lines. You can just take the first one, 0.94 gram per mil. Okay, let's look at the next mixture. All right, so we'll say mixture. For the second mixture, now the second mixture is actually, if you check through your this thing, you see that the second mixture is 10 plus 5. 10 plus 5, right? The mass of this mixture, if you look at that guy, is 13.71 based on what I gave us in the table. Please, if you look at that table, I gave us a range of values. So yours must not necessarily be 13.71, but it should be within the range of values that I gave us here earlier. Now, this is a range of value. Your own could be 13 from 13 to 14.5. It necessarily mustn't be this value here was what they gave them in the lab, what one of the lab attendants actually carried out himself and gave them this. So this is the value they got. So I just decided to use the value automatically, and I confirmed it is very, very correct. So in case you don't know what to write here, you can just use this and get your answer. But if your group actually did it, because I must commend you guys, I actually saw a lot of work from students. They really quite impressive. They got the value. So if your values are close to this, kudos, you can just substitute your values and solve. But if you're kind of confused on how your group member got the values, you can just get this and solve it as well. So for the mass of the mixture for the second mixture is 13.71. Now the volume of that mixture is 14.8. Now some persons might ask me, how did we get this? Now look up. This is 10 of A, 5 of B. 10 plus 5 is 15. But remember I said anytime you're mixing two different liquids, the expected, which is 15, expected because if you add 10 to 5 is always going to give you 15. But the real volume, which is the actual volume, would be less than 15. So that's why we just reduce it by 0.2. So this is 14.8. You can equally decide not to use 14.8. You can use 14.7. You can use 14.9. But do not use 15. All right. So we say density of the second liquid, of the second mixture. Now this is the mass, the mass of our volume, which is 13. Remember, density is mass of our volume. Mass of mixture is this. Volume is 14.8. So we have 13.71 divided by 14.8. So we have 0.926, which is approximately 0.3 grams per mil. Okay, where am I going to record this? You come back here to your table, and then please, this is supposed to be plus 10 plus 5. This is 0.93 grams per mil. All right, let's proceed again to the third mixture. I'll say for third mixture. All right, so let's get it straight for the third mixture. Now, for the third mixture, mass of the mixture, sorry, we have so we have the mass of the mixture. The third mixture is actually 10 plus 10. 10 plus 10 mil. So mass of mixture is equals to 17.5 grams. Now volume of that mixture is 19.8. Once again, this is the actual volume, right? Now the expected is 10 plus 10, which is 20. But when you mix it real life, you're not going to get 20. Obviously, you're going to get something less than 20, even if by 0.1 or 0.01. Okay, so the mass of the third mixture, mass of we have the density here is 17.5. Density is equal to mass over volume. The mass of this mixture is 17.5, right? The volume is 19.8. So we have 17.5 divided by 19.8. So we're having 0.88 gram per mil. All right, so remember, your value here must not necessarily be 17.5. Your own can be 17.9, 18.0. So I'm just giving us how to solve this. This particular one is the real way to solve this. Density is mass over volume. The mass of the mixture is 17.5. The volume is 19.8. When you divide this, you get your density. So you come back here. But we're going to record that guy. Come back here. This is 0.88 gram per mil. Now you come back to the fourth mixture. And what's the value for the fourth mixture? We have 5 plus 10. Mass of mixture gave us 12.7 grams. Volume of mixture gave us 14.8. So this becomes density equals to mass over volume. The mass of this is 12.7 divided by 14.8. So this becomes 12.7 divided by 14.8. This is 0.86 gram per mil. How are we going to write that? We come down here, 0.86 gram per mil. Okay, please hit the subscribe button. We have the fifth mixture. We have for the fifth mixture we have 5 plus 15 mil. All right, so mass of the mixture is 16.81. Remember, there are ranges upon which your value should follow. So the volume is 19.9. So my density becomes equals to, mass is 16.81, and then we have divided by the volume is 19.9. So when you do that, 16.81 divided by 19.9, so this becomes 0.84 gram per mil. So while we're going to write this, you come back here. We have for the last one 0.84. 1 2 3 4 5 1 2 3 4 5. So for the 5 mixtures we have values. Alright, the next video actually for the experiment 4 will follow suit. Please hit the subscribe button, share, and then comment if you have any question. So I'll be able to assist. If you have your table of value, you can then equally send me a message on WhatsApp, so I can just add you up to my WhatsApp group and then check out your values if necessary. Thank you.